To find a constant a and b of this function, we'll use the information below here, where x is going to be 3 on 2. And I'll substitute the 3 on 2 value of x in here. Okay, this here could be written in a better form, so I will just rewrite this again, just inverting this so that we can get it up into the numerator, and everything else stays the same. And this is supposed to be equal to 3. Now this 3 here and that 3 can cancel out, and now this is going to equal to 1. And this automatically means that everything inside these brackets is going to be equal to 1. And when I write it this way, you can see why, because this is just equal to 1. So, and using a common denominator on the left-hand side, I will continue solving it for a. So 9a minus 4b is equal to 6, and therefore a is equal to 6 over 9 and 4b over 9. I can cancel 6 and 9 and make it 2 on 3, and the 4b over 9 just stays as it is. And so we found a in terms of b, but that's not enough. So we will use this information here, that the derivative function when 3 is over 2 is equal to 30. So we'll have to now find the derivative function of this. To find the derivative of this function, we're going to have to use the chain rule, because there is a function, it's a composite function here. I will rewrite this again with this x in the numerator. This will make it easier for me to use the chain rule. And differentiating that will give me a 9, because 3 times 3 is 9. I rewrite this function one more time here, and now I need to reduce 3 by 1, so that's going to be just 2. And now I'll derive the function inside here. This says a minus, the negative here comes from the minus 1 in the exponent, b, x, and then I reduce the minus 1 in here, so that becomes minus 2. So now I intend to change those negative indices into the positive indices. And now that it's all simplified, I'm going to insert x is equal to 3 on 2 and substitute all x values for 3 on 2. So we've got the first one, 3 on 2a, and these fractions here, I will reciprocate them and put them into the numerator. Maybe at this point you might want to start expanding these brackets over here, but I am going to make use of the fact that I have an a here, which is 2/3 plus 4b on 9. So I'll use that to substitute it into my a's in here. And so I just rewrote the value of a over here, because so that I can see it's easy accessible to me, and I'll just substitute it now in. And now that I did that, I'm just going to expand this by multiplying this and multiplying this out, and moving all the these fractions into the one single denominator of 9. And if you look at this very closely, you'll notice that this 3 on 2 and can be now eliminated, and we have 1. Also 4, and this can be changed to 2, and this is 1. So we will have now 2/3 of b, okay, minus 2/3 of b, and in here we'll have 6 plus 8b over 9. Now it's clear that 2/3 b and 2/3 b will cancel, and we have, as this was supposed to be squared, and we will just have 1 squared, which is just 1. So that stays, and now we just have 6 plus 8b over 9. If you remember, that was supposed to be 30 here, so we'll equate this with 30. Now 9 and 9 can cancel, and we have 6 plus 8b is equal to 30, and that means that 8b is equal to 24, therefore b is equal to 3. And if b is equal to 3, we know that a is equal to 2 on 3 plus 4b over 9. So we can substitute 3 in there, and that will be equal to 2 on 3 plus 4 times 3 is 12 over 9, which can be put into 6 over 9 plus 12 over 9, and that will be 18 over 9, which is simply 2. So a is equal to 2. So if you found this helpful for Year 12 Mathematics, then please subscribe, and I will send some more YouTube videos very soon.